Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving Partial Pairs by Philip Newman. I'm sorry if you guys can hear some background noise or music. You don't even want to know what I had to do to get this recorded for you this morning. Really, in a perfect world, I would have remembered to record last night, but alas, that's in the past, and I completely forgot. So here we are, making the best of it. Not quite as bad as the time I had to record in the airport in Kansas City, but close, I think. I'm at my gym right now. But anyways, this puzzle is called Partial Pairs, and it is a ratio pairs and non-consecutive Sudoku. So we have normal Sudoku rules, meaning we're placing the digits 1 through 9, once each in each row, each column, and each outline 3 by 3 region. And on top of that, we have some black dots in the grid. Black dots tell you that the two surrounding digits are in a 1 to 2 ratio. In other words, one of them is twice as large as the other, such as 4 and 8, which is what this pair has to be, since we've already used up 1, 2, and 3, and we can't go any bigger. And if there is not a white dot, or if there's not a black dot, there's no negative constraint, so it's still possible that digits are in a 1 to 2 ratio. So you don't necessarily know what's going on if there's no black dot. On top of that, there is a cheeky non-consecutive constraint, meaning that digits that are next to each other cannot ever be consecutive. The only exception is if a 1 and 2, which are both consecutive and in a 1 to 2 ratio, are separated by a black dot. That is allowed. So keeping all of that in our heads, let's get solving. So we place the 4 and 8 here. We need 5, 6, and 7 in this region still, which makes this a naked 5. And then these guys are going to be 6 and 7. If we look at this column, we need a pair of digits that are at a 1 to 2 ratio, and this can't include 3 or 6, so it can't be 3 and 6. It can't be 4 and 8, and it also can't be 2 and 4. So the only other possibility is 1 and 2. That makes these guys 4 and 9 to finish off the column. In this region, we still need 3, 5, 7, and 9. We can't have a 7 or a 9 here because it's adjacent to 8, and those would be consecutive with the 8. So that has to be our 7 and 9, which will go there and there. So now in this column, we still need a 1, a 2, a 6, and a 7, and the only pair there that is in a 1 to 2 ratio is the 1 and 2, so those are going to go into those two cells separated by a dot, and because we have a 2 in row 7, we're going to make that a 1. There's a 7 in the region, so that's a 6, and that is our 7. So now these guys are going to be 3, 5, and 8. We can't have a 5 right there. We can't have an 8 next to the 7. All right, now, if we look at this row, we still need 1, 4, 6, and 9. Can't put a 6 right above a 6 here. Can't put a 9 right above a 9. So that's all we get to do with that at the moment. This ratio pair can't have a 2 or a 4, so we can't do 1 and 2, we can't do 2 and 4, we can't do 4 and 8, so the only remaining possibility is 3 and 6. This one can't have a 2 or a 3, so it's not 1 and 2, it's not 2 and 4, and it's not 3 and 6, so it is 4 and 8, which must go in that order because we already have an 8 right here. These guys are going to be 1, 7, and 9. That's not a 9. That's not a 1. And that can't be a 7 because it's touching a 6, and those two would be consecutive. All right, now right here, we can't use a 3, so this is not a 3, 6 pair. So it's either 1 and 2, which would have to go that way around because of that one right there. 2 and 4, which would have to go that way around because of the 4 right there. And it can't be 4 and 8 because we would have to put a 4 or 8 in this cell, which can't be either of those. So long story short, we know that that is a 2 either way. It's either 1 and 2 or 4 and 2. Now the remaining digits in this row are 3, 6, 7, and 9. That's not going to be a 3 for a couple of different reasons. Okay, where shall we look next? Over here, we can't use a 1 or a 2, so we need either 4 and 8 or 3 and 6, and there's a 4 in the region, so that's going to be a 3, 6 pair, which makes that an 8. And now 8 can't go next to 9 due to the non-consecutive constraint, so that's a 4. And that's going to become a 9. That means the rest of the row consists of 7 and 9. The 3 here resolves our 3, 5 by value. And these guys are going to be 1, 8, and 9. That's not a 9 because we have a 9 in that column. And that is not a 9 because we have a 9 in the row, so that's a 1. And now if we look at these two cells, I thought this was kind of charming. If this one was a 9, that would become an 8, which would make those two consecutive, breaking the puzzle. So that must not be a 9. It has to be a 7, which can't go with an 8, so that's going to be our 9. That makes this a 9. I'm going to eliminate 9 right here. I also have 7 and 9 there, so this is now a 6. Now I have 6 and 9 in the column, so that's a 1 or a 4. The 1-4 pair gives us a 9 and a 7, and then our last digit there is going to be an 8. The 7 resolves this, so I suppose I already had a 7 in the region, so I probably could have resolved that a long time ago. Okay, so we can eliminate 6 from those cells, so we have 3, 7, and 9 there. Eliminate 9 from there. And then in this row, we need a pair that are in a 1-to-2 ratio, and that's going to have to be either 1 and 2 or 2 and 4. Either way, there's definitely a 2 in one of those two cells. So this becomes a 5. That's our last digit that we need here. Now that's going to be a 9 because that's our last digit in the column. These guys will be 4 and 8, and we can't put an 8 with the 9. So that will be our 4, and that resolves these. So now we know this is not a 2 and 4, this is a 1 and 2. Okay, now to finish off this row, we need 2, 5, and 7. 5 and 2 can't go in that cell for a couple of reasons, including that we can't put a 5 next to the 4, we can't put a 2 next to the 1. So that's going to become a 7. 2 can't go next to 3, so that's a 5. And now that we have a 2 in the middle cell there, that can't go next to a 1, so that's going to be an 8, and then that becomes a 1. And that's now a 2 and a 1 in that order. There's a 7 in the column now, so that is a 3. And then we can resolve the 7 and 9 using the 7 and 9 in the central region. So now these guys are going to be 6 and 2, if I'm not mistaken. Yep. In this row, we need 3, 4, and 5. That's not a 4, so that's where we're going to place our 4, which resolves this. And here we need 3, 5, and 8. That's not a 5. We have a 5 in this row now, so that's 3 and 5. And actually, we could have eliminated 5 from there because it's next to a 6, which causes problems with the non-consecutive constraint. So now this is 1 and 5, and our last digits are going to be 2 and 7. And that is how you solve Philip Newman's partial pairs. Hope you guys liked that one. I really enjoyed that one. I think that was kind of light and breezy, especially for a Philip puzzle. If you want to solve it yourself, the link is in the description of this video. And I will see you again in 3 days.